When we ask students what they learn in calculus classes, we often hear answers like this.
I don't know why I had to take calculus.
I felt confused.
It didn't seem relevant.
I just memorized stuff.
The applications were all about finding equations for baseballs thrown off buildings. I would never really need that.
When we ask professors if students are able to translate what they learn in calculus courses into their STEM classes, we often hear them say this.
As an engineering professor, I ask my students to calculate rate of change of velocity of water flowing through the soil. Now they know how to take the derivatives, but they cannot make the connections between engineering practice and the calculus that they learn in math classes.
When examining data from UC Merced and CSU Fresno, we discovered large equity gaps in performance for underrepresented minorities. This is concerning because failing grades in Calculus 1 or Calculus 2 significantly impacts graduation rates of students.
To address these challenges with calculus, we've assembled an interdisciplinary team across 2 universities with expertise in mathematics education, STEM disciplines, cognitive psychology, and higher education administration. Our project is called Why, What, and How Calculus, and our goals are to improve success rates in first-year calculus courses, to increase persistence in STEM majors, and to close the achievement gaps for underrepresented minority and first-generation college students. To achieve these goals, we're redesigning our calculus courses in several ways.
We want students taking these courses to understand that calculus is the study of functions and their behavior, and that functions are mathematical objects that help us model and describe the world around us. We want them to have a balance of conceptual understanding and technical skills, and to be able to use the calculus tools to solve real-world applications that come from a variety of scientific and engineering fields, including those they major in. A stronger focus on the concepts of calculus rather than the mechanics.
We'll create a supportive community of learners that includes both students and instructors who work together both in and out of the classroom.
Our courses will embrace culturally sensitive instructional practices while also reducing math anxiety and promoting math interest, self-efficacy, and develop STEM identities.
Our approach to calculus reform is multi-pronged and it has 3 major components. First, we'll be redesigning the curriculum and course structure. Second, we'll be creating training and resources for instructors. And finally, we'll be developing support systems for students.
Classroom time will now be split between mini lectures and group work guided by undergraduate learning assistants. In discussion sections, students will work in groups to solve engaging, applications-oriented projects. We will transition from traditional exam-based assessment to projects and mastery-based grading in order to shift student focus away from formulaic regurgitation and towards real-world situations and conceptual understanding, while also developing a growth mindset and sense of student agency for their learning.
Instructors at both UC Merced and CSU Fresno who are interested in adopting this new approach will be provided training and resources.
Instructors will participate in training workshops on a variety of subjects, including culturally responsive teaching, equity-based practices and grading, and applications-focused instruction. An integral part of this project is the creation of support systems and environment where students can succeed. Close partnerships with tutoring services will encourage students to better utilize these resources. With the help of technology, we will connect students from across universities to provide them with access to additional materials and help from instructors, teaching assistants, and peers.
We started by listing some of the current challenges with the calculus courses. With Why, What, and How Calculus, we hope to transform how calculus is taught and how calculus is learned. We will change student impressions of calculus by showing them how applicable the material is.
I like calculus a lot, and I like being back in person because I'm able to interact with my peers and my professor.
We'll better prepare our students for their subsequent STEM courses. We'll increase the calculus success rates for all of our students and close the achievement gaps for different demographic and socioeconomic groups.